All right, higher difficulty examples of factoring power functions, factoring a cubic. Now we look at this monster right away. So this guy's equal to 0. We're trying to find its zeros. And what do? Well, a lot of people do that whole subtract 18 to the other side and pray and try to finagle math and do illegal things until you get an answer. But that way doesn't work. We got to go the factoring route. So we have to creatively come up with the things that we think go into this. So the first thing we know is that we have an m parenthesis m parenthesis m parenthesis, or we have an m parenthesis times an m squared, whoops, not x squared, an m squared sort of term with like two other parts here, a 2m and a 1 or something like that. So we have something in this form. So we know we're looking for like roots here, like -1, -9. Those would multiply to 9, and I need a 2 left over for this guy. So these could be the options for this. Or, and notice I'm taking the first numbers, and I know it has to be m times m times m, or m squared times m, to get m cubed. And I'm taking the last numbers, all my coefficients here. -9 times -1 is 9, times 2 is 18, and that has to give me this number here. So I can use those to try to inform my decision here. But all I really need to do is find one of these terms. So if you have a constant coefficient out in front here, the easiest way to start picking your terms that go into this are to just say, what are all the factors of positive 18? So it's like 1, 2, 3, 4 doesn't go in, 5, 6, 9, and 18. So plus or minus any of these could be our factors. And the long and short of it is you just gotta try one of them and see if it works. So I'm gonna pick, in this example, 3. Let's try 3. So just, I'll pick this guy to try to make it work here. So I'm going to do synthetic division just because it's a bit faster. So 3, by any chance do you go into this term? So 1, -13, 24, 18. Okay, so I didn't, full disclosure, I didn't just randomly pick that one. There's a way to actually see if this works, and it's called grabbing 3. 3 cubed is 27, minus 13 times 9, plus 24 times 3, plus 18. Well, it turns out 72 plus 18 is 90. And it turns out 13 times 9 is 13 times 10, which is 130, minus 13, so minus 117. Yeah, I knew this one was 0 because it adds to 0. So that's kind of how you pick your first one you're trying to divide into this to trying to find factors, is you pick one of these, or multiple of them, and plug them into this. So if I tried 1, for example, this one gave me 0. So I was like, heck yes, 3 is good. Let's try 1. So if I tried 1, I would get 1 minus 13 plus 24 plus 18. No, that's garbage. Like, that is not 0. The only one of those terms is negative. It's smaller than those ones. I could try like 18, and I hope you can tell that it would be like way big, and that's not a real one. So I chose 3 because it was the first one of these 12 different options that actually gave me 0 when I plugged it in, so I know it'll go in cleanly. And so now I'm going to do synthetic division with this. So I drop down to 1 times 3 is 3. Add those together, -10 times 3 is -30. Add those together, -6 times 3 is -18, and heck yes, it goes in cleanly. Okay, so now I know the factors of this are, I'm going to have an m minus 3, That's from this guy. And I'm also going to have a term that's m squared minus 10m minus 6. So again, I'm trying to find where the zeros of this thing are. So I found one of my terms. Well, now I'm going to go to another one of my handy friends because I don't know how to factor this easily. Like, there's nothing that strikes me as working using, say, this method or this method. I just don't see anything that's going to work here. So I'm going to say, hey, I know one of my zeros is m equals 3, but I'm going to look for more. So I'm going to use our good old buddy, the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This guy is a buddy. We're going to plug stuff into this. Remember, our a is 1 here. Our b is negative 10, and our c is negative 6. So I'm going to get negative 10, so 10, plus or minus square root of 100, which is negative 10 squared, minus 4 times 1 times negative 6, all over 2a, which is just 2. And these two answers are the other two solutions to my problem. So this is 24 plus 24, because the negatives cancel out, and 6 times 4 is 24. So this is really just 10 plus square root of 124 over 2, and 10 minus the square root of 124 over 2. And these are the other values of m that find us the zeros of this equation. And you may go, wow, that was a lot of work. Yeah, this is a pretty complicated one. A lot of times in questions I give you in class, it'll be a little easier, but hey, sometimes you might have to go this far. You might have to find something that goes in by trying all these and doing the little math on the side and figuring out which one actually works, and then dividing that in and being like, heck yes, it works. And then getting here and being like, crud, I can't factor this, and then using the quadratic formula. And it really can't be that much work. This is so useful in chapter 3, where we find relative extrema, critical points, maxes and mins. It's useful for optimization problems. And so having the skills to factor cubics is super useful. And that's it.